Hey everyone, how are you doing? Today we're going to be looking at Elasticsearch, and we're going to start this exploration by looking at the campground application that we've looked at and kind of played around with before. Okay, so we've seen this before. It's has 3 pages, home, search, and about. It's just a basic intro here in this home page. And in search, I can search for campgrounds. Before, I could search for the names of campgrounds, like Apache campgrounds or Taylor's Railroad. This time, I can search for words inside the description of the campground. So let's see how that works. So let's say I'm interested in forests. I'm really a big fan of forests, and I want some mountains around, so I'll type mountain. And here I get some entries. So sorry for the look, I really suck and I just don't have the patience apparently for designing good looking websites. Bear with me, sorry. So I have the name of the campground, Oak Grove. I have where it is, Ruidoso, New Mexico, and this relevance score. How well does this campground match my search for forest and mountain? And if I click there, no surprise, it looks like before. It just describes this Oak Grove. And you can see in the description there is the word forest and there is the word mountain. So that kind of matched the description. Let me do that again. So, let me do the same search, forest, mountain. And this time we kind of look further down. These are less relevant entries. Let's go with the saddle in Cloudcroft. Let me click that one. And why does it have less relevance? Well, it has the word forest, but it doesn't have the word mountain. So it found something. We were searching for a forest and mountain. It found a forest one here, but it wasn't mountain, so it got less relevance. It was lower down on the list. So that's pretty cool. So let's see how we can implement this using PostgreSQL. And let me start up PostgreSQL, or go into it. And I think my database was Parky. Okay, and so I'm interested in forest and mountain. That's what I was interested in. So select splat from campgrounds, where description equals. Okay, and it's not finding anything, and I'm hoping you think you know what's wrong and you could instantly fix it. So I'm going to just change this a bit, and instead of that equals, because that's going to look just for descriptions that only contain the phrase forest, mountain, and that's all it has. And let's say it can contain any words before that phrase and any words after that phrase. And it still doesn't find anything because it's looking for that phrase forest, mountain. Those 2 words have to go together. So let's change that and say there can be anything in between forest and mountain. And now I get an entry. So I get that entry and we can see that it has mountain vistas and oak forest surroundings are close to mountain vistas. So I have forest and mountain. Let's suppose I'm thinking, well, maybe that mountain might be capitalized or a forest might be capitalized because, there's like, if you have Oak Grove Forest, that forest could very well have been, it's a name, part of a name. So let's change that. That's pretty simple. I can just change that like to I like. And you see, we do get another entry. We get him as mountains. There is the first entry where before we didn't because it didn't match the case of mountain. So that's cool. So now we're humming along pretty well. But this only finds things that the word forest occurs before the word mountain. What happens if I don't care about the ordering and I just want, forest and mountain to be in there? So for that, it would have to change it a little bit. Let's do that. So it has to have forest and so now I get 3 rows back. So I get an additional one because one of these, I guess it's that number 3, Recondo, that has the word mountain, Jimenez Mountain Trail, before the word forest. So you see that these are getting a slightly more complex as we're kind of growing our searches. Let me change to the movie database just to have some more illustration. And suppose I'm interested in, I really like that Dwayne Johnson movie, Jumanji Next Jungle, I think it was called, or something like that. So let me see if I can find that in my movie database. So that would be select splat from movie where title I like, and let's say Jumanji can be anywhere, and title, I think it was next. Whoop. And let me just stare at this to make sure it looks reasonable. It'll probably give an error anyway, but it doesn't hurt to verify it once. Select splat from movie where title I like Jumanji. Oh. And title I like next, and title I like jungle. Okay, we get nothing back. Well, maybe I was wrong with that title. I know it had Jumanji in it, but maybe there was a next, or let me just change that a bit. So I'll change that title I like, and I'll change this to or. So it could maybe have jungle or maybe next. I'm not exactly sure. And it did find a couple. So I was a little bit off. One was called Jumanji Welcome to the Jungle, and one was called Jumanji The Next Level. And that was the query. So you see things are getting a little more complex in trying to do these things in Postgres, or in fact any relational database server. So let's continue with our Postgres exploration. And this time let's look at the titles of YouTube videos. So there's some that I've been watching recently. And let's say, I remember this video, I want to watch it again. It was something about vanning around Curry Mountain in the Yukon. I'm kind of a fan. I've never been to the Yukon, but it looks amazing from these YouTube videos. But anyway, so I think it was like vanning around Curry Mountain in the Yukon with Kira. So that's what I want to find. And if I search for that on YouTube, vanning Curry Mountain, Yukon, Kira, that entry is the first thing that shows up. Foresty Forests, Van Life in BC, Mount Curie, and Kira's Survival Pod. So that's what the YouTube video was. But let's see, how would I write that in Postgres to figure out to get that entry back? And it would be something like this, right? Where I know Curie was in there because that was the name of the mountain, and Kira was, one of the people in the video. And then it may have had the word mountain in it, or Yukon, or van. It probably did have the word van. So anyway, the point is that these Postgres queries are getting more and more complex to come up with the information we want when we're looking through kind of a string of text. When the title's long and we kind of roughly know what the title is and want to do a search for it, maybe this relational database server approach isn't really the best technique. So really, PostgreSQL or any relational database server is not the way to go when we're doing basically a search through kind of unstructured text. So these SQL database engines, they're good for column data. That's what we've been using for the most part. But it's really search engines we want. Just by the word search engines or phrase, they're good for searching text information. So they can find documents that contain specific terms out of order. So if we go forest mountain, it'll find things that, where the word forest occurs before the word mountain, and vice versa. It can score and sort documents according to relevance. So we saw that in my little demo of the campground app, that ones that matched really well had a higher relevance score and they were sorted. And it can also filter and group documents and aggregate some data. So that's what search engines do. They're really much better at this than trying to implement this in a relational database server like PostgreSQL. Let's take a quick deviation here and look at this website DB engines. And here we get, this is just entertaining, I guess, more than anything, but I like seeing, what's the current ranking of these search engines or database engines. And we see that Oracle, MySQL, and MySQL Server, or Microsoft SQL Server, are in the top three there. They've been stable all along, and Postgres is this continually rising line. And Elasticsearch does show up. Let's count, 1, 2, 3, 4, 5, 6. It's the seventh most popular of these engines. But if we go here to the left, see, we can look at any relational databases, all these different types of databases. If we look at search engines, we see that Elasticsearch is by far the most popular search engine, but there's a bunch of them. So what we're learning is what I'll be presenting today. Some of it is very specific to Elasticsearch, but in general, this is what search engines do. So you may look at Splunk or some others, and they basically work the same way. So, all right, with that little deviation, let's go back. And so we're going to be working with Elasticsearch. And the thing to impress upon you here and throughout the course and throughout your life, in every aspect of your life, is that everything is figure outable. You have the skills you need to figure things out. So Elasticsearch looks complex maybe to get started, and there's all these terms I'll be throwing out. And just remember that, hey, I can figure this out. You have the potential to do that. And there's a lot of information online. I'm just going to give you a quick kind of introduction to it, not go into great depth. Again, because this isn't a class on Elasticsearch, I'm not going to cover it for weeks, but I just want to introduce you to kind of a new tool that we can use, and for you to realize, PostgreSQL is fantastic, but it's not the thing to use for every situation. All right, with that in mind, let's go and do some installing. So the first thing we need to do, or a very simple technique, is I'm going to clone this repository. I find it the simplest way to get Elasticsearch up and running. And what this does is create 3 Docker containers. So Docker is kind of a OS operating system virtualization that enables us to run kind of small operating system-like containers. And a container can kind of isolate your code and all the libraries it needs from one another. So it's really good that way. Prior to containers, if you distributed your code to someone, you never knew what the version of what they had on their operating system, so it may or may not work. Containers are a nice way to do distribution. And the other thing about containers is that if your site gets real popular, you can ramp up by just cloning these containers. Anyway, that's a short introduction to containers. I may discuss them a bit more, but for now, let's just go with this Git Clone. And let me quit out of my database, and let me create a new, let me make a directory called Elastic. And let's do that Git Clone here. I pasted. Okay, and now let's change into that directory that I created. And now let's run it. So that would be Docker compose And when you do it, this will take a little bit longer because it has to download those containers. But it says it's done, so let's take a look at it. And everything's running. We have everything running about for 15 seconds. So now we have Docker running. And let's see how we can write some node code that makes use of this search engine, this database of documents that we can search in. So it's going to be pretty similar to how we worked with PostgreSQL. So let's just go with it. So let me move up a level here. Let me do that npm init that we've done before. Now let me install the module, just like we did when we installed PG, that Postgres module that helped connect our node code to PostgreSQL. Let's do the same here. Okay, that looks pretty cool. All right, so let's write some code. Here I am in an editor. It's start off by saying use strict. Let me save that as in my Elastic folder as just called elastic.js. Sweet. All right. And now, just like we did with Postgres, where we had to create both, we had to kind of import that information in and then create a new instance of it. It's the same with using this Elasticsearch module. And creating the instance. And the parameters, we're hooking to our locally run Elasticsearch. We're not going off in the cloud or another server to use it. It's running here locally, so that node will be, and Elasticsearch by default runs on 9200. And the authorization is the standard one when we bring it up. It's kind of a silly one, but for the purposes of demo, I'm not changing anything. All right, that looks good. And now let's write a function that puts some things into the Elasticsearch database sort of thing and does a simple search. So that's kind of my goal, is to put 2 or 3 things in and then do a search. And let's just call this function run. Takes no arguments. All right, now here's where we're going to do some inserts into the Elasticsearch. And the equivalent of kind of a table, I don't know, it's kind of a cross between a database and a table, is called the index. So index to me seems, my previous understanding of index was a little different. Index just means a collection, basically. So that's what we're going to do here. So we can say await client, we want to index this, add this. And the one argument is, what index do we want? So what is the collection name, basically? Let's call it Game of Thrones. And then what is it that we want to insert? So that's the body. And let's say there's a character name. And a quote. Sorry for all the pop-ups. So that looks good, I suppose. So that's going to insert one thing into our index called Game of Thrones. And let's do this a few times. So let's insert like 3 things. Okay, I think there's 3 things there. So the other character, give me a sec. Okay, and finally, let's insert Okay, so that should insert 3 things in the index. Now we kind of need to, it's kind of the equivalent of committing stuff. We want to re-index our collection. And that command is, sorry. And what we want to refresh is and now is when we want to actually do some sort of search. So that would be, we're going to get some result back from our search. And as you can imagine, one thing we need to know is, well, what's the index we want to search on? And that is Game of Thrones. And our query is going to be, we want to match it. And we want that quote to be, have the word book in it. Or books. I don't know, I'm bad with putting commas in. Okay, now let's log the results. So that defines our function. And now what we want to do is run our function. So we want to run and let me just pause for a moment and look this over. And let's see if this works. So I saved it. Go here. Let's make sure I have it there. And it's likely I made some error, but let's give it a shot. Oh, and I got it back. So I didn't make any error. So you see that I was able to insert 3 documents into a database-like thing, into a collection, into an index, and do a search on it. So that's how this works. Now, there are a few ways to, other than this. I mean, if I had 100 entries, I could simply just keep adding things to the entry. There's also some kind of batch ways of adding information to an Elasticsearch engine. And let me just go ahead and show you that right quick. So that is what's called Cabana, which is running on port 5601. It's one of the 3 Docker containers we created. One was Elasticsearch, one was Cabana. And that's localhost. And the username, unfortunately, is Elastic, and the password is change me. Let me make sure I got that spelled right. All right, now here we are in Cabana. It can do a lot of stuff and a lot of exploration of data, and I'm only going to show you one feature, which is how to import some information, which is a pretty useful thing. So here I'm going to go to machine learning. And here I'm going to go to Data Visualizer. And here I can import a CSV file, so up to 100 megabyte files. And let me find our very small campground CSV file that I have. So I'm selecting camp CSV. And here you can do lots of things like change the names of columns, but I'm just going to keep things pretty much the same. So I'll do that. So that's all the description there. So I can select import. And here I can create this index name, whatever I want to call it. So I'll call it campgrounds. Okay, so now we have an index called campgrounds, and it has 14 documents in it. That's what was in my short CSV file that had this information about the campgrounds. Okay, now that we've done that, we can write some code that can do some searching on this campgrounds collection. So I've already done that. So here's that code. As you can see, it's really similar to the one we did last time. So I'm searching for the index campgrounds for our Forest Mountain example. So let's go ahead and run that. So I can go node campgrounds.js, and I get that example, right? So I get these values, And one thing that's nice about this is I get that score. So this was 1.14. So that's where in my interface, that's where I got those scores, 2.795. So this one's a really good match. And it does it in order. So that's it. That's all I wanted to show. Just kind of a basic introduction to Elasticsearch and give you enough to kind of start your very simple exploration. So with that, one task is to implement that site I just showed you, that campground search site. And so let me just show you that again. So let me go home. So there's home, search, and the standard about that I never changed. But that search was, I could search for forest, mountain, and I get these results, and I click on them, and I get that information. So that's the task. The project has to do with this vast collection we have. The largest email collection that's publicly available is the Clinton email collection, and we'll be working with that. It's a very similar task, just a larger amount of data, and I'd like it running on Google Cloud. The task, of course, can run on your desktop. So thanks so much for watching. Take care. Bye.